Hello, so what we want to talk about in this section are some applications of trigonometric functions. We'll cover several. As you can imagine, there are many applications, but one of the most basic applications is solving a right triangle. Now, you've done some of this in a previous section, but we want to go back over it and extend it to solving for missing angles as well. But all of these problems are going to involve a right triangle. So see, I've got an example of a right triangle for you. Now, this one, we really don't know it's a right triangle, not officially. I mean, how do you know this isn't really like 89 degrees? So you're always going to be given this little square in the corner. It may look more square than that one, but you're always going to be given some square in the corner to help you identify the right angle. If that's not there, I wouldn't guess that it's right. I mean, it might look right, but you really don't know it's right. And what we're going to do in this section, it truly has to be a right triangle to apply the ideas or the theorems that we're going to use. Okay? Now, how about how we're going to name this right triangle? Well, the angles in this textbook always use capital letters. Okay? So we could call this angle A, okay, this angle B, and I think your book typically calls the right triangle angle C. These are all capital letters, whereas the side across from C is called side C, and that's a lowercase c. The side directly across from A is called side A, and that's a lowercase a. And then finally, the side directly across from B is called side B, and that's a lowercase b. And when we solve right triangles, what we're going to be doing is we're going to be calculating what is A, what is B, what is C, and what is lowercase a, lowercase b, and lowercase c. Now, of course, you're going to be given some of this information, like right off the bat, even from this picture, we know that angle C is 90 degrees because that's your right angle. But you'll be given two more bits of information. And to solve a triangle, whether it's right or not, in future sections we're going to solve triangles that are not right triangles, but you always have to have three known bits of information. And so I'm going to be giving you two more bits of information when we start solving. But we're not going to solve yet. Now what I want to do is go back and review something that you already know. First of all, we know that that's our right side, okay? And I've got another right triangle right over here for you. And again, this is still angle C, angle B, angle A, and of course this is side C, side B, and side A, just our naming convention. But when you discuss an angle that's not your right angle, you need to name it. Okay, often we might call that theta, or it would be angle A. Okay, now y'all know this, the side across from angle A, we term that our opposite side. Okay, the side adjacent to angle A that's not the hypotenuse. So you might want to go ahead and name this is the hypotenuse, and again the side adjacent to angle A is going to be the adjacent side. Okay, so we need to know this, and it matters if you're talking about this angle or if you're talking about this angle. These things change when you're talking about B. So let's talk about a different triangle. What if theta was our B? Okay, so let's look at it from a different point of view. What if this was my angle that I was looking at? So I'm looking at B up here where this is C and this is A. The side across from B, this time, this is opposite. This is across from the hypotenuse, therefore, from the 90-degree angle, therefore, it's always the hypotenuse. And then the side next to B is adjacent. So I don't want you to have in your head that every triangle has the same opposite and adjacent sides. It depends on the angle that you're discussing, okay? So let's solve our first problem. We're going to solve the right triangle shown in the figure. They want us to round our side lengths to 2 decimal places and express our angle to the nearest tenth of a degree. So make sure you always read the directions about where to round on these problems. It should always say, okay? Now what I do when I start these problems is I go ahead and write down A, B, C. So I'm going to answer what all the angles are, and then lowercase a, lowercase b, lowercase c. And get some of this information we already know. For example, angle C over here, see the square in there. That means that's our 90-degree angle. okay? It says angle A is 21 degrees and side A is 3.2. So notice we do have 3 bits of information, and you're always going to have 3 bits of information to be able to solve any triangle. Okay, now I can put on my picture the 21 degrees. There's my 21 degrees, and then A over here is 3.2. So let's actually solve to find the remaining B, the side B, and side C. Okay, now as you can probably imagine, we have an option of where to start first here. Some of you might notice right off the bat that if I have 2 angles, then, you know, the total of these should add to 180 degrees. If I have 2 angles, I can solve. So let's go ahead and find angle B. So angle B is going to equal to 180 minus the 2 guys we already know. So minus 21 minus 90. And that gives me B is equal to 69 degrees when I type that in my calculator. So now I have one more bit of information to fill into my list. Okay, the next thing I want to do is change my pen color. But after that, let's focus on finding either side B or side C. I'm going to go ahead and find side B. Now, how am I going to do that? This is where I need a trig function. Okay, so I'm going to work with angle A. Now, if I'm working with angle A, remember, across this way is opposite. This guy over here is my hypotenuse, and this guy down here is adjacent. But that only applies if I'm referring to angle A. If I was referring to angle B, then this would be opposite and this would be adjacent. This is always a hypotenuse 100% of the time. But now let's work with the 2 things we know. So I need a trig function that deals with opposite, the one I know, and adjacent, the one I'm looking for. So I ask you what trig function has opposite and adjacent in it, and y'all all know that's tangent. So I can say tangent of my angle, which is 21 degrees, is equal to opposite, which is 3.2, over adjacent, which I'm just going to call B, right? Okay, so again, reminder, this is coming from opposite over adjacent, which is tangent. Now I'm solving for B. So we must do the algebra to solve for B. My next step is going to be to multiply both sides of this equation by B. I can't solve for it if it's in the denominator. So I'm going to multiply by B here and multiply by B here. How did that help? Those B's cancel. So now what I have is B times the tangent of 21 degrees is equal to 3.2. I'm trying to get the B by itself, so what am I going to do? I'm going to divide by the tangent of 21, divide by the tangent of 21. So my answer for B is going to be 3.2 divided by the tangent of 21 degrees. Now my next step is to go to my calculator, make sure I'm in degree mode, real big degree mode. Alright, and that's actually true for every problem in this section, degree mode. And I'm going to type in 3.2 and divide it by the tangent of 21. And when I type that in my calculator, I get 8.33628. It keeps going. It says round side lengths to 2 decimal places. So we're talking 8.34 units. And that's my B value. So I'm going to put it up here, 8.34. Now I still have to find C. Okay, so to get some space back, what I'm going to do is erase a little bit over here. I think we're all comfortable with the fact of how we got our missing angle, 180 degrees minus your known angle. And I'm going to use this space to find C. Now you be thinking about how in the world are we going to find C? Okay, all right, well, 2 ways you can do it. Y'all know if you have A and B, you can find C whenever you have a right triangle. You can use the Pythagorean theorem. You can say 3.2 squared, that's your A squared, plus 8.34 squared is equal to your hypotenuse, which is what we're looking for, squared. So I type this in my calculator to get 79.7956 equals c squared. I take the square root of both sides to get a result of 8.93. Now again, that's rounded, so c equals 8.93. Now that's not the only way to find c. You could also work with, you're working with c, right? So you could say opposite is a side we know. We're looking for c. You're talking about opposite and hypotenuse. What trig function has that? Sine. So you could set up the sine of 21 degrees equals 3.2 over c and solve for c just as we did here, but using the sine of 21 degrees instead. I think this is easier. I have seen people do it both ways. I've done it myself just to make sure I had it right. If you get the same answer both ways, you can feel very confident that you've done this correctly. So we have another right triangle problem I like to label. So it says A is 54.8. So there's my angle that's 54.8 degrees. We know side C is 80, and we're still looking for A and B. So let's write down what we're looking for. A, B, C, all uppercase, so angles, and then lowercase a, b, and c, which depicts the sides. I know that angle A is 54.8 degrees, and angle C is 90 degrees. I know that side C is 80. So that's all the given information. Notice we're given 3 bits, and we're looking for 3 bits. Now once again, I know 2 of the angles, so immediately I could find angle B by doing 180 degrees minus 54.8 degrees minus 90 degrees. And when I type that in my calculator, I have 180 minus 54.8 minus 90, and I have 35.2 degrees. So I'm just going to write that over here. Don't forget to write your summary. There we go. Actually, I meant to do that in a different color because we found it. I'm just going to circle it. Okay, and now let's work with a different color. I want to find either side A or B. I'm just going to go with A first because it's first on my list. Now, compared to 54.8, notice A is the opposite. So A is opposite, B is adjacent, and C is hypotenuse. Okay, and again, this is in terms of where A is. So opposite, adjacent. So I'm looking for the opposite side right now. I need a trig function that has opposite, the one I'm looking for, and hypotenuse, the one I know. Okay, I can't work with opposite and adjacent because I don't know either one of those values. So I have to work with the one I know. So what is a trig function that is opposite and hypotenuse? And you all know that's sine. So I'm going to set up sine of 54.8 degrees is equal to opposite, which is A, over hypotenuse, which is 80. Okay, and again, how do I know that? Because this is opposite, hypotenuse. Y'all have memorized that that is sine. Now my next step is going to be to simply multiply both sides by 80. So by 80 over here, by 80 over here, and that gives me the next line of 80 times the sine of 54.8 degrees is A. And I'll just type that right in my calculator. Again, what mode should you be in? Degrees. So 80 times the sine of 54.8 gives me 65.37. So A is 65.37. That is rounded to the hundredths place. Okay, now to find B, remember you have an option. You can either work with another trig function, adjacent over hypotenuse, which would be cosine, and do this exact same work but with cosine, or you can use the Pythagorean theorem, and let's say side squared, so 65.37 squared, plus B squared, we don't know B, equals to 80 squared. Okay, so I'm going to say B squared is equal to 80 squared minus 65.37 squared. Type that in my calculator. 80 squared minus 65.37 squared. That gives me 2,126.76 that I'm going to take the square root of to get an answer of 46.12, and again, that's rounded. So B equals 46.12. Make sure you use your calculator and you see where that's coming from. Okay? Don't just assume that that's going to go fine in your calculator. Make sure you check it. Alright, so I bet you think you have this mastered, right? Solve the right triangle. But notice this time we're given different information. We're not given an angle. We're given that side A is 11.2. That doesn't look anything like an 11. Forgive me, let's try this again. 11.2. And side C is 65.8. Alright, now what are we looking for? Again, angle A, angle B, angle C, side A, side B, and side C. Okay, fill in what we know. A is 11.2 and C is 65.8. And don't forget 90 degrees. Notice, again, we're given 3 bits of information. We're still looking for 3 bits of information. Now, if you want to, you could go ahead and find side B, couldn't we? We could use the Pythagorean theorem. Okay, so we could say A squared, which is 11.2 squared, plus B squared, we don't know, equals C squared, or 65.8 squared. And then I'm going to subtract the 11.2 to the right, so that would give me B squared is equal to 65.8 squared minus 11.2 squared. And then B squared will equal whatever that is, and let me just tell you what that is. So 65.8 squared minus 11.2 squared gives me 4,204.2. Not rounded. Don't round in the middle of this. That's not the way to go. You don't round until the very end. Now take the square root of that, and I get an answer of 64.84. Remember, that's a side length. So side B is 64.84. Okay, now we're supposed to find angle A and angle B. Let's find angle A first. Okay, so right here, that's what I'm looking for. Now, in terms of angle A, 11.2, you agree, is opposite, and B would be adjacent, and C, up here, 65.8, of course, is the hypotenuse. Now, you always have to work with 2 bits of information that you know. We don't know the angle, but we know opposite and hypotenuse. So what trig function has opposite and hypotenuse in it? That's sine, correct? So I can say sine of A equals opposite, which is 11.2, over hypotenuse, which is 65.8. Okay, now what do we do when we don't know the angle and we're trying to solve this trig equation? Well, this is when you use your inverse trig function. Okay, so if I take the inverse sine of A, that's just going to give me A equals, and I take the inverse sine of this side, 11.2 divided by 65.8. Okay, now remember, you need to be in degrees because our answer in angles needs to be in degrees. Even though in the last section when we defined inverse trig functions, we were working with radians all the way around, but all of that could be extended to degrees just fine, and that's what happens in this section when you're working with triangles. So in your calculator, again, degree mode, very important, degree mode. Okay, and then I'm going to type in the inverse sine, so you need to hit your second button, inverse sine, and it's going to be 11.2 divided by 65.8, and I get a value of 9.8. That's rounded. Remember, our lengths are supposed to be to 1 decimal place. Okay, the nearest tenth of a degree. Oh, wait a minute. No, I'm sorry. This is an angle. Okay, so I need 2 decimal places, right? So round side lengths 2, I got it backwards, and the angles to 1. So how about 9.8? I said it right to start with. And remember, that's degrees. Okay? Now, do we need to use another trig function to find b? You certainly can if you want to, but it's not required, right? If you have two angles, then to find the third angle of a triangle, that's not a problem at all. What do you need to do? Well, you need to do 180 degrees minus the 2 you know. So we're going to say that angle B is 180 degrees minus 9.8 degrees minus 90 degrees. I type that in my calculator. Again, 180 minus 9.8 minus 90, and I get 80.2 degrees. And we're finished with that problem. So here we go again. This is the last to solve a triangle. I think after this, well, like this, and then I've got some different ones for you, and I'll do that in the next video. But solve the right triangle shown in the figure. Round side links to two decimal places. I've already got your answers set up over here on the right. Let's fill in what we know. It says A is 5. So here is 5. B is 11. And we don't know C or our side. So let's fill in again what we know. A is 5, B is 11, and angle C is still 90 degrees. Let's find anything else we can find. And if you notice, we can go ahead and use the Pythagorean theorem to find C. So I have 5 squared plus 11 squared is C squared. So 25 plus 121 is C squared. So that would be what, 146 equals to C squared. I take the square root of 146, and I get an answer of 12.083, and that keeps going. Side links are supposed to be rounded to two decimal places, so 12.08. All right, now let's see if we can find angle A or B. I'm going to just start with angle A because it's listed first. Now, in terms of angle A, straight across, y'all, that's my opposite side. So opposite is 5. Okay, my adjacent side is 11. And my C value is always my hypotenuse, no matter which angle, A or B, that you're referring to. So if we're going to find angle A, then I need to work with the two sides I know, which is opposite and adjacent. So what trig function has opposite and adjacent as its definition? Okay, well, how about tangent? Okay, so I can say tangent of A is equal to opposite, which is 5, over adjacent, which is 11. And again, just to remind you, that's just coming from this definition, opposite over adjacent. Now, our goal is to solve for A. So to get rid of A on the left, what you have to do is take the inverse tangent of that side. Well, that cancels to give you A, but you also have to take the inverse tangent of the right side. And that's where the work comes in. So I'm going to type in my calculator the inverse tangent of 5 over 11 in degree mode. Never go to your calculator in trig without thinking about what mode you're in before you type in anything. So inverse tangent of 5 divided by 11 gives me 24.44395. Remember, this is degrees, and our degrees are supposed to go to the tenths place. So 24.4 degrees. All right, now to find our third angle, we can do our trick of 180. So B would equal to 180 minus the two guys we know, 90 degrees and 24.4 degrees. I'm going to type that in my calculator, 180, subtract 90, subtract 24.4, and I get 65.6 degrees. Now that's the last problem that I want to sneak in this video. But come back for another video. We're talking about solving more triangles, just slightly more complicated, and we'll do some word problems and some bearing problems.